Hi, my name is Alex.
And my name is Tao Trong.
And I am Patrick Meixton.
And we are Group 2, the Multiple LED Cube Controller.
In this video, we will first give an overview of the Multiple LED Cube Controller. Secondly, we will discuss some of its unique requirements. Third, we will give a more in-depth description through a block diagram. And finally, we will be giving a timeline and summary. Let's get started with the overview.
The obvious question arises: if there are so many LED cubes, why do another? Our project will be different in 3 distinct ways. First, our LED cubes will be more accessible. Currently, you have to know a lot about hardware and embedded programming to use LED cubes. What we want to do is make an LED cube for the layman and for software programmers. Second, this project addresses the problem that as an LED becomes larger, more designs can be programmed onto it, but it also becomes more complex and more expensive. Our LEDs will come in individual cubes that a user could use on their own or could combine to make a larger LED cube. Third, end users will be able to control the cubes actively. Meaning, if the cubes were displaying a game, the user would be able to use their computer to actively control what is being displayed on the LED cube.
Next, we have the requirements. To accomplish these 3 goals, we will need to achieve some technical requirements. The first goal is that the LED cube needs to be built for laymen and software programmers. This will be partly accomplished by the requirement that the GUI can work on Ubuntu 12.04 and Windows 7. Many software programmers use open source systems like Ubuntu, while laymen use Windows 7. So it's important for our GUI to be able to work on both of these systems. The GUI should also handle the hardware aspects of the LED cube so that the users will be able to easily use and modify it. The second goal is for our LED cubes to be expandable. This calls for our next requirement that a pattern can utilize the connection of another LED cube within 10 seconds of connection. Connection is when 2 or more LED cubes are drawn together and held in place by their magnets. For the end user, this will be a simple experience of just sliding the 2 LED cubes together. How this happens will be described in our Hall Effect sensor block. Our third goal is for the user to be able to actively control the LED cubes. This brings us to our next requirement, that the system is capable of allowing the user to actively change what is displayed on the LED cube, with the cube responding within 10 seconds of user input. Essentially, this means that the user changes through the GUI will be displayed on the LED cube quickly. There are many more requirements that will not be covered in this video. For now, let's move to a more in-depth look at how we will construct the LED cube in our block diagram.
The GUI, or Graphical User Interface, is the basis of how the user will interact with the LED cubes. It will be programmed in Python because of the programming language's simplicity and its ability to create an aesthetically pleasing and user-friendly interface. The GUI receives inputs from the user and sends those commands to the LED cube. The GUI sends those commands through the wireless transmitter attached to the computer through USB. The computer's wireless transmitter is the Zigbee chip. Zigbee is a wireless protocol like Bluetooth or Wi-Fi that we chose because of its low power, simplicity to use, and reliability. The Zigbee chip is then able to send data to the LED cube's wireless transmitter. The LED cube takes the data from the computer's wireless transmitter with another Zigbee chip. The Zigbee then sends it to the microcontroller.
The controller block is going to be a microcontroller, which will be like the brains of the LED cube. The controller will need to perform 2 main tasks. First, whenever a signal is sent through Zigbee, the controller needs to determine if that signal was meant for that particular LED cube. And if it was, what does that signal mean? The second task the controller needs to perform is controlling which LEDs are to be lit and when. The controller cannot directly power the LEDs though, so it will have to send a signal out to the LED drivers through SPI, the serial port interface, also pronounced SPI. There were multiple protocols that could be used for sending wired communication between multiple devices. We chose SPI because it was simple and it could also be used to communicate with the Zigbee module. Now, in addition to these two tasks, the controller will also need to control which layer of the LED will be turned on at a time. Essentially, the reason we need to do this is we don't have enough power to turn all the LEDs on at the same time. So what we're going to do is go through and turn each of the LEDs on and off quickly enough that it'll look to the human eye like they're all being turned on at the correct time. For a more in-depth look at how the LEDs will be controlled, let's go over to Alex.
To control the LEDs, there are three necessary blocks: the level decoder, the LED array, and the LED driver. The first block is the level decoder. This block controls which level of the LED cube is currently active. When the controller block sends an 8-bit binary number to the level decoder, it selects one of the 8 outputs as the current level. We are only going to have 5 layers in total, which means that once one of the 5 is selected, it is connected to a transistor, which acts as a switch, since the level decoder cannot output enough current to power the LEDs. Next is the LED array. The LED array is a simple block consisting of 125 red, green, blue LEDs shaped in a 5x5x5 LED cube with resistors to prevent pulling too much current. Finally is the LED driver block. This block is programmed via SPI to control which of the 25 LEDs is turned on a single layer. We will be using 6 LED drivers, 2 for each color, to control the entire level. When the LED drivers are programmed, they will pull the current necessary to activate the LED. The last block I'll be talking about is the Hall effect sensor block. The Hall effect sensor block detects when there are nearby magnetic fields. When a magnetic field is detected, the Hall effect sensor allows current to travel through it, which the microcontroller block would read. All of the LED cubes have Hall effect sensors and magnets on each side, which allows them to detect when 2 or more LED cubes have been placed together.
Week 8. Currently, we are at a point where we are working on research on the technical aspects of our project. We are getting familiar with the hardware and software we will be working with and preparing ourselves for prototyping. Week 10. We should have all the necessary and extra parts to implement our multiple LED cube controller. We want to have all the parts by this time so that there are no delays and unnecessary wait time while we are building and prototyping. Winter break. Our group will be developing and building our first prototype. Getting a head start on building our multiple LED cube will leave more time for troubleshooting later. Week 11. Once school resumes, we will continue developing the prototype and troubleshooting any problems we run into. With more resources available while school is in session, troubleshooting will be smoother and easier to do. Week 13. When we reach this week, the prototype will be finished with minimal to no bugs. This will lead us into developing the rest of the hardware for communication purposes and user interaction. Week 15. We will have all the hardware completed in working order. Having our hardware done lets us work more in depth with the software programming aspects. Week 18. Finally, the software should work reliably with our hardware after any troubleshooting along the way. We will then have time to reinforce and improve our system so that it meets all the engineering requirements.
For our project, we have defined our overall goals, made technical requirements to achieve these goals, made an in-depth block diagram, and laid out a timeline for our project. With these, we should be able to make a fun and interesting project by spring term. This project is the culmination of the experience we have all gained in electrical and computer engineering here at Oregon State University. On behalf of all of us here on Group 2, I would like to thank you for watching our video presentation on
The Multiple LED Cube Controller.